All right, all right, all right. Thanks for joining us. So, I just got this video to show you guys. You might have already seen it this year, but it's still super cute. That's Sammy. My dogs. That's Max. That's Max. And that's Sammy. They're both golden doodles. Sammy's a little special. He does something kind of special. It is.
Good boy.
Best yawn ever. Best yawn ever. So thanks for being here. Thanks for watching. We're just finishing up here on 9.3. So now the main event, we want to draw a reference triangle and find the trig ratio for the angle possible without a calculator. What? Okay, here we go. It's not too bad. So first of all, where is pi over 4? So if, oops, no, let's start on 21. So if you're not sure where 5 pi over 6 is, you could always convert it to degrees, right? So I think we could count it as well. Remember how to count it? So how we count it is by pi's over 6. So right here is 1 pi over 6, and that's 30 degrees. And so then we got 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. That wasn't too bad. That wasn't too bad. So all the way to here is 5 pi over 6. The reason why I extended that line was so that we could draw a triangle. And the reference triangle specifically, so if that's 5 pi over 6, how much more would get us to 6 pi over 6? Which 6 pi over 6 is pi, or 180 degrees. Yeah, so how much more is that? So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Okay, so what's 5 pi over 6? How do we get to 6 pi over 6? So we go. So we go, reference angle, we go on pi over 6 radians. And pi over 6 radians is the same as 30 degrees. So this is basically a 30, 60, 90 right triangle. So we're going to go and draw that triangle there. So this is a 30, 60, 90 right triangle. That means the short leg is going to be 1. The long leg, that's the short leg. The long leg is going to be radical 3. And then the hypotenuse is going to go ahead and be 2. Remember, because from 1, you double to get to the hypotenuse. So 1 becomes a 2. 1 times 2, or 1 times radical 3. Cool. So there is our right triangle. So now we're going to label opposite, adjacent, hypotenuse from the reference angle. So from our reference angle, this 1 is actually the opposite side. Opposite equals 1. Now we are going up, so that stays positive. So it is indeed a positive 1. But then we're going left, so this is actually negative. And so that's adjacent to the 30 degrees. So we call this the adjacent side. And then over here is the hypotenuse side, which is always positive. Hypotenuse is always positive. Hypotenuse and reference angle. Memorize it. Memorize it. The hypotenuse and reference angle. Reference angle is always positive. Cool. Always positive. It's always positive. Always positive. Okay, so now they want us to do tangent. So what is tangent again? We did a lot of work there. What is tangent? So tangent is opposite over adjacent. Okay, so let's find opposite. So opposite is positive 1 over adjacent, and adjacent is negative radical 3. So now we just need to rationalize the denominator. And so that means that we're going to go ahead and times by radical 3 to the top and bottom. And so our final answer is going to be 1 times radical 3 is radical 3, divided by, it's going to be negative. Don't forget the negative. And then radical 3 divided by radical 3 will be 3 times 3 is 9. And the square root of 9 is 3. So we get negative radical 3 over 3 is our answer to tangent of 5 pi over 6. Okay, so try number 20 now. Try number 22. You got this. They're not too bad. 20 and 22 are pretty good. Pretty good ones to practice on. Okay, let's do 5 pi over 3 again. No, 5 pi over 6. Okay, so 5 pi over 3, good. That's a different one. So let's try 23 next. So what's cotangent? So cotangent is not opposite over adjacent, it's flipped. So it's going to be adjacent over opposite. So we've got to do the adjacent side over the opposite side when we find it. But first, we've got to draw our triangle. Okay, let's see here. So we're going to go ahead and turn 5 pi over 6. So 5 pi over 3. We want to turn it into 6. So we're going to times it by 2 to the top and bottom. And that's going to become 10 pi over 6. And now we're going to go ahead and count all the way around to 10 pi over 6. Y-axis, x-axis, here we go. Let me see here. So we're going to go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This, of course, is 6 pi over 6. This was 1 pi over 6. So we have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. There it is. So that's where 10 pi over 6 radians is. So we'll extend that line a little bit to make our triangle. And now we're going to make a reference triangle. Draw a line up to the x-axis. There's our reference triangle. Good. There's our reference triangle. Okay. So now we need to figure out what that is, the reference triangle. So how much more to get to 12 pi over 6, basically? So we have one more, which is 11 pi over 6. And then our final one is 12 pi over 6. So how far is that? Well, that's 1 plus 1, right? 1 pi over 6 plus 1 pi over 6 more to get to 12 pi over 6, or 360. And so that's going to be 2 pi over 6 more. And 2 pi over 6 is the same as pi over 3, which is 60 degrees. Now, if you're not sure, you could go ahead and convert that. So you would do pi over 3, and you would times it. Do you remember how to convert it to degrees to make sure? So you times it by what? 180 over pi. Pi's cancel. You're left with 180 over 3 is equal to 60 degrees. So this is a reference of 60 degrees for our reference angle, okay? So that's our reference angle, good. So then we're going to go opposite of that. Ooh, that's the long leg. So the long leg, do you remember? The long leg is radical 3. Do you remember? So basically it's, so you have 60 degrees, opposite of that is radical 3. You have 30 degrees, opposite of that is just the 1. We default to 1. And then the hypotenuse, or 90 degrees. So the hypotenuse, or 90 degrees, is going to be the 2. And so that's what you place in your 30, 60, 90 right triangle there. So opposite 60 is radical 3. That's also the opposite side. And then the adjacent side is going to be opposite the 30 degrees, which is the short leg, so that's just 1. And that's a right one, so positive 1. And then down, we're going down. So that's a negative radical 3. And the hypotenuse is always 2. Cool. So here we go. We need the adjacent side over the opposite side. So the adjacent side is positive 1. Positive 1 over the opposite side. And the opposite side is negative radical 3. Way-o. Now we do need to rationalize the denominator. Rationalize the denominator. So we're going to go ahead and times that by radical 3 over radical 3. And so we end up with, on the top there, we got 1 times radical 3 is radical 3. Divided by 3 times 3 is 9. Square root of 9 is 3. So we get negative radical 3 over 3 if we rationalize the denominator. So 1 over radical 3 is definitely true. And so I think it has to do with the slide rule, why we have to rationalize the denominator. Interesting, huh? History of math. Okay, so now cosecant. So cosecant is going to be what? So cosecant. Have you paused me yet? You need to pause me. Try it on your own. Pause me. Try it on your own. Pause me. So cosecant is, what is cosecant? 1 over sine. So it's basically sine, flipped. So instead of the opposite of our hypotenuse, it's hypotenuse over opposite. Cool. So then what we do is we draw our negative pi over 4. So this is, do you remember what that is? So this one is right here. That's a 45, 45, 90 right triangle. And that is our 1 pi over 4. And in case you didn't learn it in class, you can actually count by pi's over 4. So that's 1 pi over 4. This is 2 pi over 4. This is 3 pi. These are all the 45, 45, 90 right triangle angles. So 3 pi over 4. 4 pi over 4 reduces to pi, or 180. So that's technically 4 pi over 4. This is 5 pi over 4. This is 6 pi over 4, reduces to 3 pi over 2. And then we have 7 pi over 4. And then this is 8 pi over 4. And 8 pi over 4 reduces to 2 pi, which is 1 full circle. So where is negative pi over 4 is the question. So up, positive pi over 4 is that way. So now we're going to go down. We're going to go down. So we're going to go ahead and go down negative pi over 4. And so right here is this angle right here is going to be a negative pi over 4. And so that's equivalent to the, so the reference angle then, right? What's the reference angle? So that's just the same thing, going that direction, but it's the same thing. And so that's going to be positive though, remember? Reference angle is positive. And so it's going to be positive pi over 4. Or what is that in degrees? 45 degrees. Whoops. 45 degrees is what that is. So we have our 45, 45, 90, right triangle. 45, 45, 90. And so opposite, if you remember, opposite that will be 1. And it's a positive 1 to the right. So that's why it's positive. But then, oh, wait, that's a down one. Whoa, 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 whoa. So this one is opposite, and this is actually negative 1 because we're going down 1. We're going down 1. So this is the opposite side, and that's a negative 1. Now this one's going to the right, so this one will be positive. And that's a positive 1, and that's adjacent to our 45 degree angle. Now we see the hypotenuse, and the hypotenuse is radical 2. And again, that's always positive. Always positive. Always positive. And so that's going to be a radical 2. And so they want hypotenuse. So our hypotenuse is, that's this guy right here. That's our hypotenuse. So that's going to be, it's going to be radical 2 all over the opposite side, which is negative 1. So the answer is negative radical 2 is the answer. There we go. Good job. Thanks for learning all these with me. Thanks for learning. So let's try one more really fast. We're going to go super fast on this one. So go ahead and draw an x-axis and a y-axis. Good. So we're going to go 1 pi over 4, or negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. Do you remember how to count these? No, that's not right. That's not right, Newbold. That's not right. Sorry, I was going too fast in my head. Okay, let's try that again. Okay, so that's not right. Okay, so we'll do line across. So that's negative 1 pi over 4, or 45 degrees. Negative 2 pi over 4, good, you're almost there. Negative 3 pi over 4. And then here's negative 4 pi over 4. Right there. And then way up here is negative pi over 4, negative 5 pi over 4. So it's going all the way around to there. And so our reference angle then, right, our reference angle in green is just going to be this angle here to the x-axis, and that is going to be just 1 pi over distance of just 1 pi over 4, right? It's going to be 1 pi over 4 or 45 degrees. So this is our 45, 45, 90 right triangle. Okay, so then opposite of that, we'll be going to the left. No, that's going up, Newbold. So that's a positive one. And then a negative one for the adjacent, which is going to the left, because this is going up, and this one's going to the left. Okay, so negative 1, positive 1, and the hypotenuse is always positive, radical 2. Nice, nice. Okay, so now we're looking for sine, and so we have sine of negative 5 pi over 4. I feel like I'm missing something here. Like sine is always positive there, isn't it? I'm a little worried now, actually. Okay, so sine of negative 5 pi over 4. Let's take a look. No, we're good. So it's going to be on opposite over hypotenuse is sine. So opposite positive 1, hallelujah, over the hypotenuse. And the hypotenuse across 90 degrees, so over radical 2. And then we're going to rationalize the denominator. And so rationalize the denominator, we're going to bring it up to the top. So 1 times radical 2, all over 2 without the radical. That's it. That's our answer. Cool. Okay, so keep on busting through these, all these even problems. Use your calculator to find the following 3 digits, but make sure your calculator is in the correct mode. Cool. So this is just plugging it in. So make sure your mode's correct. So for example, number 29, let's take a look there. So tangent of 2 pi over 4, that is a radian. So we're going to change to radians now instead of degrees. You hit the mode button to change it. Hit the mode button. So we're going to go ahead and do tangent of 2 pi over 5. That is definitely not a 30, 60, 90, 45, 45, 90 right triangle, so you have to use the calculator for that one. And so that is 3.0776. 3 decimal place accuracy, so 3.078. Yeah. 3.0776. 3.0776. There's approximately 3.078 is our answer for 3 decimal place accuracy there. Cool. Okay. So then keep on trying, keep on trying. Ooh, cosecant 2.7. What the? Is that a degree? No, because degrees are bigger than that. Degrees are like 30, 25, 199. Usually that's 90, so it's 45, 56. Yeah, so we're going to say that that's a radian then. We're going to say that's a radian, right? That's a radian. So still in radian mode. So cosecant, what is cosecant? So cosecant is 1 over sine. Cosecant is 1 over sine. So this is going to be 1 divided by sine of 2.7. And that's in radians. So then we go 2.7. There we go. Make sure you're in radians. So 2.339 runs up to 2.340. So 2.340. Did you get that right? Okay, try 32, try number 30, try number 33, 34. You got this. So don't forget that cotangent is 1 over tangent of 320 degrees. And now you have to change your mode. Change your mode back to degrees. So make sure you change your mode back to degrees. So we go mode, back to degrees, back to degrees. So second quit, second quit, second quit. And then we go cotangent. So 1 divided by tangent of 320 degrees there. Nice. So we get negative 1.1917. So negative 1.192. Negative 1.192 is our answer. Okay, thanks for watching. Keep on going. You got this. Ace those problems. You got this. Thanks for watching. You behind the screen. Thanks for watching. And thanks Ron Campbell, our head custodian who retired today. He gave me Sammy, that dog that just yawned earlier. That's thanks to him and his dog, his mommy dog that gave us one of her children. Big Boy is his name, and we called him Sammy. So thanks for watching. And peace out. Bye for now.